All right, we're going to talk about slope today, and we can also call slope rate. That is how fast something is changing with the inputs. So we did look at some patterns in previous uh, sections that we did, okay? So let me change my color here. So we can see that the very first one is 3. If there was something, if we were to go backwards, we could also think about that. If I go to the next one, then we can see there's 5 stars there, right? 5 stars. Then if I go to the next one, we added, there's 2 more, 7. And so that pattern's going to continue, right? And what we were having is each time we're increasing by 2, okay? So the rate is 2, because for every input, remember we talked about inputs, the x values, the output are the y values. And our function, what would it be our function here? If we went backwards, this would be at 1. So the very start is at 0, okay? So we add 2, okay? We had 1 star here. If we go back, we could say, there's 1 at the 0 step, okay? Our function here is the output is equal to, we increase, the rate is 2 for every input, x, plus 1, okay? And then we can test that at all these points, okay? So here, let's see if it equals 3. If we take 2 times 1 plus 1, okay? Because I said the rate was 2, that would be 3, right? 2 times 2 plus 1, that's 5. Okay, don't worry about finding out these functions, I gave it to you. But the rate that it's changing for every input is plus 2. And we could have rates that also decrease. That would be fine too, right? Another similar case here, if we were going up, if we go up 1, let's see what happened there. It looks like they added 4, right? Because they went like this, right, on each corner. So adding 4, and then again here, we're adding 4. So the rate here is 4 because we're increasing by 4. Now, if we were to flip this around and put this one first, and then we would be decreasing by 4. So our rate would be -4. So we can have positive, we can have negative rates. It just depends on the situation, okay? This one, we've gone from 1 triangle, and it looks like we have 1, 2, 3 triangles. We increased 2. This one is not a linear pattern, because if we look at this one, we increase by 2, so we went plus 2, right? Because it went from 1 to 3, and then here we take that and we multiply it by 3. We could say this is, instead of adding 2, it's times 3. That's really what the pattern is, times 3. That is not a linear pattern. A linear pattern is when we're adding the same amount or subtracting the same amount for each input. So this is not a linear pattern. All right, so let me go, and I want to talk about slope today. Another word for slope is rate, the rate of change, okay? And we're going to also notice on graphs what that does on a graph. Okay, so a constant rate of change is that slope. Now here's another example where we have a slope of 2. Okay, how do we talk about slope? You're thinking about going up stairs. If we were going up a set of stairs, if you're going up a set of stairs to like a mall or something, you might see something like this, right? Like these little stairs like this. And that's not such a steep slope. That's kind of gradual, right? And then maybe if you're in a little tiny apartment, you'll see these very steep stairs, or not even an apartment, but like a camper or something really small, right? So then we have much greater rate The rate is higher, the slope is higher. How do we measure the slope? We have to measure it with how much it's rising for every input. How much is it going up, right? How much did it go up for each step? And so we give a symbol for slope is m. Always now remember m is equal to the slope, okay? The slope is equal to the rise, how much it rises for every step. The rise over the run. Okay, the run is right here. And the rise is here. Okay, so we're measuring slope, rise over run. And we can have positive or negative slopes. And we always read our graphs from left to right, just like we read in English and we read with numbers and math. So if you see from left to right, so as I go from left to right, is it going up? If it's going up, that's increasing. We would call that a positive slope, okay? If we go from left to right and we're going downwards, okay, this would be a negative slope, right? Oops. Negative slope. This is a positive slope. All right, so that's the basics of it. Let's look at some examples where we're going to determine what the slopes are. So the first thing I want to do is I want to determine what the slope is from a graph, okay? And you can see that I made a little triangle here, okay? And one of those represents the rise, up and down value, and the other one represents the run. I'm just going to go ahead and label those. So this is the rise here. And then we have the run here. Okay, so I'm gonna start from my left point and I'm gonna see, okay, well, if I go from this point here, which is labeled there, right? Actually, the point is at 1, 0, okay? And this one is at 4, 5. Let me double check that. 1, 2, 4, and 1, 2, 3, 4, 5. Good. Okay, so how many units are we rising? So how many units are we rising? Well, we start from here. 1, 2, 3, 4, 5. And this one's kind of easy to see. So the rise is 5. And then for the run, we must always rise before we run. So think about it. If I'm going to run, I have to get up first. You must always rise before I run. And then we do our run. 1, 2, 3. So we have a run of 3. So our slope, m, is equal to rise over run. That would be 5 over 3. And we could simplify that, or we could rewrite it as a mixed number. We can't simplify it, though. That's it. And it's a positive slope because it's going up from left to right. If I have a negative slope, I'm going to have to count down and go to the right. All right, let's look at an example of another example where I want to determine what the slope is. Remember the slope formula. You don't need to remember this, like memorize it. The slope formula is rise, that's the up and down part, right, over the run. And always remember we must do the rise before we do the run. We're going to start with the left side here. Oh, this one's going down, right? So I'm going to start here and I'm going to go to this point here. So my rise is going to go down 1, 2. So that's 2 units. And it's negative 2 because I'm going down. And then the run is always to the right. 1, 2, 3, 4. So that's 4. So in this case, m is equal to the rise, which is negative 2, over the run, which is 4. And we can simplify that fraction, right? So m is equal to a negative slope. What's 2 over 4? Okay, common factor is 2. It's a half, negative a half. Okay, that is the slope. We're going to determine the slope. And what we're going to do now is we're going to go ahead and practice determining the slope from a graph. Okay, so we're going to start with the leftmost point, and we're going to go either up or down. Okay, so our rise is it up or down? Down is negative. Okay, and then we'll do our run. Just keeping in mind that positive slopes, if we go from left to right, are going up. These are positive slopes. Negative slopes are going down if we go from left to right.